All right, ladies and gentlemen, welcome to WiSE Women in Science and Engineering Seminar Series. This is a new program here at VCC starting in January 2012. The Women in Science and Engineering, WiSE, is committed to the recruitment, retention, and advancement of underrepresented groups pursuing careers in science and engineering. WiSE is open to all students, and there are blue pieces of paper going around for you to sign your name and email address for us to tell you about some of the upcoming things WiSE will be doing here at VCC. Not only will we have our seminar series, which starts today and will continue on the third Thursday of every month, including through the fall semester, we already have our speakers lined up. In the future, we will be expanding WiSE with workshops on careers, resume building, and graduate schools, networking for future schools and employment, local excursions to labs and facilities where you may be working in the future, get behind-the-scenes tours, career mentoring, and undergraduate research. Starting research even before you leave VCC to get your foot in the door. Today we have our guest speaker who is going to be talking about seahorse and pipefish research in the Indian River Lagoon. On Thursday, February 16th, we have Dr. Sutton from the Florida State College at Jacksonville talking about DNA analysis in crime laboratories. Thursday, March 15th, we have Dr. Ann Spellman from Florida Fish and Wildlife. We'll be talking about marine mammal strandings, rescues, and research. And Thursday, April 19th, we have two engineers, Ms. Lamb and Ms. Strab from the city of Melbourne on engineering. We hope that you will continue to come to our seminars and participate in future activities with Women in Science and Engineering. It is open to all students. All right, I would like to welcome up our guest speaker. This is Sarah Craigie, who will soon be Dr. Craigie from the Florida Institute of Technology. Thank you.
Thank you guys very much for having me. I'm currently a PhD candidate at Florida Tech. I'm in the Department of Marine and Environmental Systems, which is actually in the Department of Engineering. So it's kind of an interesting place for somebody who's very biology related to be. And today I'm going to talk to you about a variety of topics about how I got to where I am in my career. And I'm actually going to present to you some of the research that I conducted for my master's and part of the research that I'm doing for my PhD, and hopefully we'll be graduating in May. So I'm busy writing and analyzing and all that other stuff. So just to kind of go through some of the different topics I'm going to cover, tell you how I got started, what different internships I've had throughout my career that have been very valuable to me. I will say this again, that internships I think are really key to making yourself very successful in the marine science field. You might be wondering what stigmathids are and what makes a stigmathid a stigmathid, so I'm going to cover just some general information about this group of organisms. Talk to you a little bit about being a master's student, my master's research, a little bit about my PhD program and my PhD research, and kind of tell you where my life is hopefully headed. So why did I go into a career of marine science? I'm originally from just outside Chicago. I was born and raised there. So there's not a lot of oceans near Chicago. We have a big lake, Lake Michigan, which is like an ocean, but not really. So most of my interest in marine science came from watching movies when I was younger. There are just a couple of silly ones I thought of. There's Splash with Tom Hanks. This is probably way older than any of you guys are. And obviously Little Mermaid, that came out when I was in second grade, so that ages me. And I think just watching movies and seeing these fish and marine mammals and things like that on TV just seemed exotic and interesting and adventurous. And I think that's what originally caught my eye into the world of marine biology. And also from when I was little, I was just very interested in conservation. They used to send these really cute like wildlife catalogs to my house, and tell you ways that you could be a better citizen in the environment, you know, turning the water off when you're brushing your teeth, things like that. So I was just immediately attracted to the idea of conservation. When I was going from high school into college, I was looking at, you know, which was going to be the best school that I could go to. And for me, it was very important to go as far away from Chicago as possible. So that was me way back in the day, and as far away as humanly possible I could get. I was looking at Hawaii, I was looking in California, but kind of showing you how things change. Is that blinking? I don't know why I'm blinking. Sorry, technical defect.
No signal.
Just click the button.
While we are fixing our technical difficulty, I wanted to introduce myself. My name is Dr. Spring. I teach here at BCC biology for majors, for non-majors, marine biology, oceanography, anatomy and physiology, environmental science, many things. My co-host for these events is Dr. Mary Roslanowski, who is our Associate Provost here at the Melbourne campus, as well as a chemistry teacher. And we would be happy to field any questions that you have, as well as ideas that you have for women in science and engineering in the future, needs that you feel we can fulfill through the WiSE program here at BCC. Thank you.
Thanks. So getting back to me. So I had this really strange notion when I was younger about what a marine biologist was. I wasn't picturing marine mammals. I wasn't picturing whales and dolphins. I wanted the furthest thing away from the cuddly SeaWorld picture of a marine biologist that you would imagine. And I wanted to be a hardcore, real marine biologist. And for me, people that lived in Florida and studied marine biology were not that. So I'm here, obviously. I've changed that opinion. But when I was looking for schools, I wanted to either do stuff in California or stuff in Rhode Island. I wanted the cold water. I wanted to work with fish in the abyss. I thought that was the ideal, you know, picture of what a real marine biologist was. And obviously Florida, I didn't even look at schools. Didn't even want to go there. So I ended up choosing Roger Williams University, which is located in Bristol, Rhode Island. And I actually saw pictures similar to this when I looked at the website for the first time. I was imagining the school on the water, and Rhode Island always just seems like a very interesting place to me. I'd never been, and it's where I wanted to go. And some of the reasons why I chose this as a school was it was small. It's very similar size to Florida Tech, and they don't have a graduate program. So for me, it was very important to be able to conduct research as an undergraduate, and I saw that ability in Roger Williams. Initially, when I was going to school, I thought I was going to become an aquatic vet. I had gone to the Shedd Aquarium in Chicago, and I just fell in love with it. It's a beautiful institution if any of you guys have ever had the opportunity to go. And I thought that helping animals within the aquarium would give me that fulfilling need of, you know, making a difference. But it would also give me access to a variety of different animals in the marine world, and I thought that that would be something I'd really enjoy. So actually before I started college, when I was a high school student, in between my junior and my senior year, I attended Sea Camp San Diego. And I was obviously very enthusiastic and my first real experience in marine science and totally fell in love with it. So I was actually asked to come back the following summer as an intern. So I was able to teach students that were coming into the program. I dove in the Channel Islands, I swam with sea lions, I swam with sharks, I snorkeled off the Mexican Coronado Islands. It was just a fabulous time, and so basically got paid and fed to hang out and do all these amazing things with marine science. And that was actually my first exposure to the world of cygnathids. One of my kind of requirements for my internship was to take care of the aquariums that they had for educational use. And I had to design an aquarium of my own. And around the island that we were staying on, there were tons of seagrass beds, and it was filled with pipefish. So I collected pipefish, and I collected seagrass, and I tried to make an aquarium. And this is back in the day when there wasn't a ton of information on the internet yet. And it was really hard to figure out how to care for these pipefish. So it was kind of my first introduction to them. When I actually started school my freshman year, I got involved with some winter flounder research, and I was actually doing the hardcore science. So winter flounder, winter in Rhode Island, it is cold. You're wearing waders, and underneath the waders, you're wearing layers of sweatshirts and sweatpants. and you wade your flood and you end up soaked anyway, and trying to deal with these, big giant nets full of these winter flounder, and it was fun. It was exactly what I wanted. My freshman year, I saw a flyer in our dorm for an internship opportunity with the Audubon Society of Rhode Island. They have an environmental education center that was right down the street from the school. So I went ahead and applied there. And I kind of bring up this story because if I wouldn't have had my internship with Sea Camp San Diego, I wouldn't have gotten this internship. They flat out told me that because I had experience working with aquariums, that it really set me apart from the other people that were applying in my same year from my discipline. So they were really excited that I was coming in experienced. So I got the job, and they have a very nice aquarium, series of aquariums there that I was able to work with. And then it ended up developing into a position with them where I was a naturalist and I was teaching birthday parties. So imagine trying to explain tide pool animals to about 10 two-year-olds at a birthday party. And so I learned a lot of public speaking skills from that position and how to take very complicated scientific information and try to whittle it down for the public. And just at least try to have somebody understand some aspects about the marine environment and how humans interfere with that marine environment at times. So it was a very interesting and very fun internship that I had. And then in between my freshman and my sophomore year of college, I applied for an internship at the Shedd Aquarium in Chicago because I knew I was going to be going home over summer break. And because I had experience working with pipefish at Sea Camp San Diego, and because I had experience working with aquariums at the Audubon Society, I got a very competitive internship my freshman year with the Shedd Aquarium. So with that internship, I was obviously very honored to get it, but I was also a little disappointed because the person that interviewed me was actually the head of the Signathid exhibit at the Shedd Aquarium that they had running. And I wanted, from my internship experience, to work with as many animals as possible, many different types of animals, to try to help guide me in which organism I was going to be studying throughout my career. And I figured Signathids, there's only a couple of them. This is going to be boring. This is not what I was hoping for. And obviously, what I expected once again was wrong. And this internship ended up being one of the most important experiences in my career, definitely, and it's really shaped what I've done with my life since then. So big thing, and it also introduced me to the world of Signathids. So let me introduce you to this amazing group of animals. So the term Signathid actually comes from the family Signathidae, and it includes both seahorses and pipefish. And there's an estimated about 35 species of seahorses right now. It changes from year to year. They'll do genetic analysis and they'll find out 2 species are actually the same, and then they'll actually find new species as well. And then there's hundreds of species of pipefish out there. And you can just see the diversity of the group. Some of the other relatives of Signathids that we still call Signathids, but they're not really part of the family Signathidae, are the sea dragons, if you've heard of and seen in aquariums, the weedy sea dragons, the leafy sea dragons. And there's some lesser known relatives. There's shrimpfish and snipefish and the trumpetfish as well that are also related. So obviously, probably a lot of you are here because you like Signathids, and the rest of you are here because you're getting course credit, so good for you. But what makes Signathids so attractive and what makes people interested in them? The first thing that you notice about them is they're unusual. They have a very interesting anatomy. Some of the specifics of it are they actually don't have any scales like a regular fish would, and they have a thin layer of skin that covers the outside of their body. And underneath that skin, they have really strong, rigid plates that give them that kind of rugged shape that you see. They don't have a well-defined stomach. They actually just have a very long esophagus, and then one area where the stomach would be, it's just a little thickened. So that means that they eat very quickly, and they absorb their nutrients very quickly as well. So when you're keeping a seahorse or a pipefish, you actually have to make sure that they have plenty of food items, otherwise they will starve. So they don't have a way to store their food with the stomach. They have independently moving eyes, just like a chameleon. So one's looking up here, and one's looking over there. They have a prehensile tail, which is usually what people notice most about them. With the pipefish, it's very extreme, where they use it to grasp. Pipefish have different levels of how they utilize their tail. Some of them don't really use it to grasp at all, and others of it actually do grasp it fully like a seahorse does. So there's a lot of variation in the pipefish group. And then they have this amazing ability to camouflage. They're able to change the color depending on which habitat that they're in. There's a lot of social behavior associated with the camouflage as well. One species of seahorse, the line seahorse, which is common in Florida, can be black, white, red, orange, gray, any color in between that you can imagine. And a single individual can change all of those colors depending on the habitat, depending on the social interaction. So it's pretty cool. And then along with camouflage, they're actually able to produce skin filaments over their body, which are like little hairs, and that helps them blend into the environment even more. So pretty cool. And one of the famous things about cygnathids is their mode of reproduction, which you guys may or may not know about. In seahorses, it's the most extreme, where the males have a fully enclosed brood pouch, and the females will deposit eggs inside of the male's brood pouch, and he'll actually incubate them. And the inside of the pouch is actually very similar to a human woman's womb. There's a placenta-like structure that forms between the epithelial layers inside of the pouch and each of the developing eggs. There's fluid inside of it very similar to the amniotic sac in female humans, and that changes as the pregnancy progresses. It changes more from an amniotic fluid to the external salinity and the conditions in the water where the seahorse is. So by the time the juveniles are ready to be born, they're actually swimming inside of the pouch in regular seawater. So it's a very cool incubation that they do. In pipefish, there's a lot of variation. There's some pipefish that only do ventral gluing, so the female just glues the eggs on the underside of the male's belly, and there's no pouch whatsoever. Some pipefish have little flaps that they use to cover the eggs, and then there are other pipefish that have a fully enclosed pouch, but they don't have all of the same internal structures that a seahorse would. And there's also a very involved mating ritual that goes on with the seahorses and pipefish for them to be able to choose a mate. Most seahorses are considered monogamous, so they mate for life. If a pair is broken up, the female will eventually find another mate, but for each of the pregnancies that the male has, the eggs are only from one female, so that's how they're able to keep that monogamous life history. And there's a lot of variation in pipefish, but there is one species of pipefish called the ghost pipefish that is extremely monogamous, and they have been known to die without their partner. So it's pretty cool. I think seahorses are pretty cool, so I'm going to keep saying that. But because seahorses are so attractive and people really enjoy having them and looking at them, their populations are really in jeopardy. And some of the major trades I'm going to talk about, the first one is the curio market. If any of you have been to a shell shop in Florida, you're going to see dried up seahorses that are there. And this is a picture of some seahorse keychains that somebody made. If you go to Walmart in their craft section, you can find dried seahorses that you can use to decorate your house. And these are wild collected individuals that are alive and just hung out outside of the water until they die. So it's kind of a cruel death, and in my opinion, it's sort of a waste of resources. The other major trade is the aquarium trade, and this is both public aquariums and home aquariums. And same thing, organisms are taken out of the wild and put inside of these aquariums. They have very specific requirements. It's not impossible to keep a seahorse in captivity, but you really have to do a lot of research to be able to feed and care for them properly. There's been a lot of developments in this area, and there's amazing resources that you can find online to successfully keep a seahorse or a pipefish, but that wasn't true in the past. And then the other trade, which is one of the most important ones, is the traditional medicine trade, and that might be a little bit foreign to everyone in this room, but over 200 million seahorses are removed every year for traditional medicines throughout the world, and it's typically in Asian markets that this happens. But the wild populations are being depleted so quickly that the trade is now being observed in areas of the Caribbean where there still are decent amounts of populations that can be collected. And these individuals are dried. They're ground up into pills or put into drinks or soups. And they're used to treat a variety of different health conditions, including asthma, liver dysfunction, kidney dysfunction, as well as sexual dysfunction. And you may think, well, does it actually work? And there's actually a whole body of scientific literature that identifies the different chemical components within the seahorse, and it has been scientifically shown to treat a variety of different illnesses. And then the last and also very important issue with cygnathids, this gets outside of the trade, is that they inhabit some of the most endangered ecosystems in the world, including seagrasses, coral reefs, and mangroves. So not only are they being heavily exploited in a variety of different trades, but their natural habitat is also being lost as well. So at the time, working at the shed and learning all of this information, I fell in love with the the kind of unique aspects of each of the seahorses and pipefish I was working with and their relatives. And then this whole idea of the conservation need is really desperate with these organisms. So obviously, as a young marine biologist, this was, oh, I can do something. I can help the situation. So I really started looking, and the aquarium at the time was looking into seahorse aquaculture. And the idea behind that is you breed seahorses in captivity. There are some people that were using it as a stock enhancement. So in like the Philippines, for instance, and New Zealand, they'd breed the organisms and then release the babies back out into the wild. But most of it was for use in the traditional medicine trade and then also for home and public aquariums, being able to breed these organisms, raise them in captivity. At the time that this really began, there was very little success in breeding and rearing the young of the seahorses. But the whole idea was if we can grow them like crazy in the lab, then we don't have to take them from the wild. So at the Shedd Aquarium, I began conducting research on a variety of different species of seahorses. The first one is actually this picture, which is Hippocampus capensis. It's the only endangered species of seahorse still. It's called the Nyctina seahorse. It's from South Africa. They occur in 2 little estuaries in South Africa. And there's a lot of habitat devastation that's going on, and that's why this particular species is endangered. And they're actually incredibly easy to raise. It was beyond simple. I had, 70% success rate with the individuals that I was raising. And then I just kept getting harder and harder species and just became very fascinated with research. So before I left the Shedd Aquarium, I started my internship in May of that year, and then in August, I was asked to stay on for a semester as an aquarist and continue my research. So I actually took a semester off of school and continued on at the aquarium doing my research. And when I was getting ready to go back to Roger Williams in my sophomore year, the spring semester, I worked on writing an undergraduate research grant that was available through our department. And I was able to get the grant. I got $1,700 to establish a seahorse breeding and research program at our school. So once I started my program and started the research, I've got the Shedd Aquarium donated animals to me. 2 professors who became very interested in the research that I was doing, and there was an opportunity through Sea Grant Rhode Island. They wanted to start up an aquaculture initiative throughout Rhode Island to encourage shellfish culture as well as any other type of finfish culture that people were interested in doing. So my professors and I, we got together and we wrote a grant, and we were awarded $250,000 over the course of 4 years to do marine ornamental aquaculture. So we raised clownfish, seahorses, and ornamental shrimp. And so my project kind of got absorbed into that, and we were able to hire generations of undergraduate students, and some of them have even now come from Roger Williams to FIT to continue on their master's degrees and PhD as well, one of them now. So it's been a really successful program, and we did a lot of really fun research with that. And I ended up, the main project I was looking at was the effects of temperature on the gestation and the rearing of, I tried actually the capensis, so the endangered seahorse, and we had problems with that population. There was a genetic bottleneck, and I ended up working with the line seahorse. And I was able to present my research at the World Aquaculture Society, and this is my senior year. And my school sent me to Honolulu, which was pretty nice. And I got to present there, and I was at a party, one of the get-togethers that they have for the conference, and I was talking to a student from FIT, and I said I was looking for somewhere to do my master's, and he dragged me over to his advisor, who had been dying to work with seahorses, and said, "Here, Sarah, you saw her presentation. She wants to, do her master's degree." He's like, "Come to my school." So I did. So just, it was like 2 months later, I was down at Florida Tech. So during my master's, I actually was given a teaching assistantship. So I was a lab instructor for molluscan and crustacean aquaculture, and I also managed the Aqua Lab, which is how I met Dr. Spring. And that's just one of the ways that you can get funding to be able to do your master's research that's available to students. So as you kind of continue on your career, you can either look for research assistantships or you can look for teaching assistantships. So with that, I got a stipend. So I have a salary that I got. My courses were paid for. So I didn't have to pay any money to be able to get my master's degree, and they actually paid me to do the work there at the lab. So it's a very good arrangement if you're able to get one. And as I was setting up the lab and working with the seahorses there, I became very interested in working with feeding kinematics. And now I'm going to show you some of the data and kind of describe to you what is feeding kinematics and issues like that. So when you're using feeding kinematics, you're obviously studying feeding. Biologically, it's very important to understand how a species feeds, what a species feeds on. You can apply these findings to aquaculture. If you understand these principles, you can take better care of the juvenile seahorses. You can take better care of the parent seahorses as well. And there's a variety of different studies that you can do to understand feeding. One common one is doing gut content analysis, collecting wild organisms, preserving them, and then looking at what they actually eat from the wild. You can do a prey selectivity study where you collect not only the organisms from the wild, but you collect samples of zooplankton and macrofauna from the area, and you compare what they eat versus what is actually available in the environment. And you can do observations as well and see what they're actually eating, either in the lab or in the field, and the field is pretty hard. But understanding how they eat can be very difficult because it's a lot of behaviors, and behavioral data is just historically very hard to quantify, and it tends to be a lot of qualitative data. Another way you can study how they eat is by taking a preserved specimen and looking at the muscles and bones and manually manipulating them to see how they all work together. But when you're not actually seeing in real time how a seahorse is moving their mouth, you might be overestimating, stretching out muscles past where they would go or stretching out bones bigger than they would normally expand. So a great way to study feeding is the use of feeding kinematics. So this utilizes a high-speed video that you can actually record a feeding event, and you can slow it down and look frame by frame. And there's a variety of different variables that you can measure, and it will give you some kind of quantitative values to compare in different feeding events. And you can compare this as well to the morphology of the organism, how long it is, how big their head is, and so on. So there's three main phases in a feeding event. This is a little juvenile line seahorse here as an example. There's a preparatory phase where the seahorse recognizes the prey in the water column that it's ready to attack. It usually has a head down position, and you'll see his eyes roll forward and begin to focus on the prey item. So that's the start of the preparatory phase. And then there's a very explosive, expansive phase. And the head will move from that head down position and all of a sudden smack up very quickly into kind of a larger head elevation. Their snout will move very fast, and at the same time that their head is moving, their mouth is opening both vertically and horizontally. And the opening of the mouth and the dropping of this little bone under their chin creates this huge change in pressure between the outside water and then what is inside of their mouth. And that action is what creates the suction, which pulls the prey from the water column into the mouth of the seahorse. So that's the expansive phase. There's a lot of things going on at that point. And then there's the recovery phase. Once the prey has been captured, then everything kind of goes back to normal to what it was like in the preparatory phase, so they can eat again. So there's, like I said, a variety of different variables that you can measure from videos like this. I'll just go through some of them really quickly. There's a series of excursions, and these are just different distance measurements. You can measure how big the seahorse opened their mouth. There's that very important bone on the bottom of their mouth called the hyoid, which helps increase the volume of the mouth. And you can see how far that depresses. There's the displacement of the snout. How far did they actually move from the preparatory phase to when they were at maximum gape? Then how far did the actual individual move from the preparatory phase till they actually captured the prey item? And then there's a series of timing variables. How fast did it take them to get to maximum gape? How fast did it take them to depress that hyoid completely? I looked at how fast the snout moved while they were capturing the prey, because it might change depending on how fast the prey item is. And then there's an angular excursion, which is how far did that head actually bend during the course of the feeding event. And you can see in that case, it really straightens out. There was one other study that was done with seahorses, and they used videos, they manipulated specimens, and they tried to create a model that would predict how seahorses would feed. And their model was unable to predict the feeding event, and it suggested that seahorses are able to change their feeding behavior in different situations, and they weren't sure what those situations were. So for the purposes of my master's, I had lots of questions. I'm an overachiever when it comes to experiments. So my first question was, can adult seahorses change their feeding behavior based on different prey types? And we call that feeding modulation. I wanted to see if adult and juvenile seahorses fed differently. I wanted to look at if juvenile feeding behavior changed over time, if different species of juveniles fed differently. And then I wanted to look at the juvenile feeding behavior if that changed with different diets. So if there was a juvenile feeding modulation. Take a little drink. Excuse me. So the results of my feeding modulation study, I'm just going to go through some of the graphs and stuff really quickly. But for this study, I used 3 adult individuals. I gave them 3 different types of prey. One was a live brine shrimp because had sea monkeys. This is just an adult sea monkey. Frozen mysid shrimp, and then I used live ghost shrimp as the 3rd prey item. The seahorses are put in a small aquarium. The high-speed video is set up in front of it with lights. And you just basically watch for them to strike at something, and you click a little button, and the video will record. So here's an example of an adult female. And you can see a little shrimp in the corner. And this is about 1/10 the actual speed of a feeding event. So I did a variety of different statistical analyses. I won't go into that quickly. I did ANOVAs, and if it was non-parametric, the variable, I did some non-parametric analysis. So for the distance variables, there was a significant difference between the ghost shrimp diet compared to the brine shrimp and the frozen mysid. When I looked at the size that they opened their mouth and the depression of the hyoid bone, there wasn't a significant difference between the 3 diets. The time that it took them to reach the maximum gape and to depress their hyoid was actually faster with the ghost shrimp. And the change in head elevation and the speed at which their snout was moving was fastest and largest in the ghost shrimp treatment. So some general conclusions from this study, I know it's very fast, is that seahorses feeding on the ghost shrimp had the largest maximum excursions and the largest angles as well. And that suggests that when they're striking at a ghost shrimp, they're actually feeding at a greater distance away from the prey item as compared with the other diet. And then seahorses feeding on the ghost shrimp had the fastest timing variables and then the fastest speeds as well with the ghost shrimp. And this suggests that they might be able to tell the escape potential of the prey item. So if the ghost shrimp, if it gets startled, it will swim away very quickly. Whereas the other 2 prey items, one was dead, it was frozen, so obviously it's passive. And then the brine shrimp are also a very passive prey. So it could just be the potential escape of the predator or the prey item is what is driving how they're feeding. And there's been other studies with kinematics on other species of fish that have shown that fish are actually able to tell from different species of shrimp which one is going to be escaping fastest, and they will feed differently on the different escape potentials of the prey items. So that actually might be occurring in the seahorses as well. So with the comparison of the adult seahorses with different stages of juveniles, I compared them to day 1 juveniles, day 7, and day 14. And the juvenile videos that I did for this, you put them in a very tiny chamber. It's only about this big. And it has a little grid in the back, and you set up the camera right there. And we used fiber optic lights in this case so it doesn't heat up the water and cause any additional effects on the babies. So here, the distance, again, was very different in the adults compared to the juveniles. The adults had much smaller distances compared to all 3 stages of juveniles. The angular excursion was different between the adults and day 7 juveniles, but everything else was the same. And I'll chat about that in a second, why that might be. And then for all the other variables that I measured, there was no significant difference between the adults and the juveniles, which was a little unexpected. So with the distance variables that were significantly different, it's suggesting that the adults are actually feeding on prey items closer than the juveniles are. So the juveniles are feeding from a greater distance away. The day 7 juveniles are actually feeding on the most elusive prey item overall. So that's probably why they're different than everyone, than the adults in particular. They're feeding on the juvenile Artemia, which are very fast swimmers compared to the other items. And just overall, while there were differences between the adults and juveniles, there were also a lot of similarities. And the juvenile seahorses are very well developed compared to a larval fish would be. So because they have a little bit more development than a fish that would be around the same age, it could just be that they although the structures aren't as well developed as an adult, that they still have enough of those structures to be able to feed similarly to an adult. So it's kind of interesting. So the next study I did, I compared 3 species of seahorses that are found in Florida. They were juvenile erectus, which is the line seahorse. The reedii is a long snout seahorse. And then the zostri is a dwarf seahorse, and the maximum adult is only about that big. And then the other guys are about this big. So quite a big difference in size range with the adults. But the juveniles are not that different from each other. But you can tell the morphology there, there's quite a difference. These are all the same age. So for here, I had multiple broods from multiple males. I raised 25 individuals from each one of the broods. I filmed 3 individuals every day, feeding 3 different times. So I have a lot of videos that I had from this one. I'm not going to show you any graphs because there's 100 graphs, and it's crazy. But one of the surprising things was the long snout seahorse, the H. reedii, was one of the smallest species of the 3, and it actually had the largest mouth and the largest hyoid depression of the other ones. So in aquaculture, one of the important things is trying to understand what prey items are actually going to fit into the species you're trying to raise as mouth. So this information is very helpful to show that this particular species actually has a very large mouth, and it can eat prey that you may not think it would be because it is a smaller total length compared to the other ones. And there was actually a very interesting difference that I saw between the long snout seahorse and the line seahorse. These are the 2 bigger ones. And those juveniles are actually platonic right after birth. And the other one, the dwarf seahorse, is benthic right after birth. And there were a lot of differences between those groups of seahorses initially. And as the platonic seahorses started to settle out and become more benthic, those similarities started to shrink until they were all basically feeding the same way. So it seems like depending on where they are in their life history is going to change how they're feeding. And there might be some very interesting differences in feeding behavior in platonic organisms like a seahorse compared to the benthic seahorses. So the last one was I looked at one species of seahorse, and I looked to see if they fed differently on different diets. So the first diet was a very elusive natural prey item called a copepod. And then I fed that for the first 5 days. And then the other group got a more aquaculture-friendly species, which is called a rotifer, which is very passive. And the copepods, because it's a natural prey item, they're full of all of these nutrients. And it's something that people in aquaculture really want to be able to use to rear organisms, but it's very difficult to grow in high densities. So it's kind of everyone would love to have it, but we really aren't there yet to be able to use it regularly. Whereas rotifers, you can go in really, really high densities, but it's nutritionally poorer. So there's some issues with using it. So I wanted to compare, well, is their feeding really that different between these 2, the natural prey item versus the aquaculture prey item? And copepods are considered an incredibly elusive prey item. The speeds that they can travel at are very quickly. But they have kind of an interesting pattern of swimming where they'll hover, and when they get startled, then they'll move very quickly out of the way of the predator, and they can get triggered to get startled very easily. They actually can sense the wave motions coming off of a predator, and just the displacement of the water is enough to trigger them to get out of the way. So that's for those reasons, the speed at which they can travel and their sensitivity to the water, they're considered a very elusive prey item. And so we expected there to be faster timing variables here for them to open their mouths larger because it is a larger prey item. And we actually found the opposite was true. And I think the main reason for that is because of how the seahorses actually fed on them. They didn't try to feed on them when they were swimming away. They waited for them to be perfectly hovering in the water column before they made their strike. And the seahorses are able to feed so quickly that it doesn't cause that water displacement. And they're able to capture this basically motionless copepod within the water column. So it was kind of unexpected, but it makes sense for how they're feeding. And by having the videos, and I'll show one of them, you'll be able to see how they are able to capture that copepod. And so even though these 2 groups of seahorses were fed with different diets and they did have different feeding behaviors in the beginning, once they were weaned onto the same food, those differences started to decrease. So in terms of feeding, there wasn't any noticeable benefit. The lengths were the same, everything like that, by giving them the more natural prey item for a small amount of time when they were first born. So it was kind of an important finding for aquaculture purposes. And I'm going to take a second to just play the video here. Baby seahorses eating. Not going to lie, it's pretty cute. that was my master's research. Okay, so just to kind of summarize some of the conclusions from my master's is that adult seahorses do change their feeding behavior based on the type of prey. There are differences between adults and juveniles, but there's also some similarities. Juvenile feeding does change over time. It varies between species, and it does vary with diet as well. So lots of complicated things going on. So that was 2 years of research, 1,700 videos of seahorses feeding. And at the end of my master's, I really came to the conclusion that aquaculture on seahorses is possible, and it's not that hard to do. You just have to kind of have the right balance of different variables. But I started kind of questioning, is it really environmentally friendly? I had, because I was working in an aquaculture lab, I had the ability to travel around to a bunch of different institutions. And some of the institutions were great, and they were really taking care to analyze the genetic quality of the organisms that they were culturing. They were trying to minimize disease or loss of animals into the environment. And then there were other ones that just weren't putting the effort up front and the money up front to be able to make their aquaculture facilities as environmentally friendly as they should. So for me, I was kind of exhausted with the aquaculture business. And I started looking through the literature and realizing that all of this effort was being spent on culturing seahorses and studying the biology of the seahorses, but so much was missing about their wild populations. And also for me personally, I wanted to be a professor at this point. I wanted to do research. I really loved teaching. And I just felt like at the end of my master's, if I was to continue with marine bio and continue with working in the lab, I wasn't going to be as well-rounded of an individual as I wanted to be for my students in the future. So I really wanted to study more of the ecology of these organisms. So I sort of switched gears from doing 2 degrees in marine biology to wanting to go into a PhD in oceanography. And you might wonder what's the difference between a biological oceanographer and a marine biologist. So a marine biologist, you study the seahorse, you can study their feeding, you can study how they swim, how they breed, different chemicals that they produce. In oceanography, you can still study the seahorse, but you have to study it within the larger context of their environment. So seahorses in their natural habitat, so for this species, seagrass, you have to worry about what food is out there. You have to worry about not only what the seahorse eats, but what eats the seahorse. And then all of this is happening within a water body. So you have a variety of different physical and chemical issues that are happening not only on the organism you're trying to study, the seahorse, but it's also affecting the food that they're eating, it's affecting the predators that are consuming them, and it's also affecting the habitat that they live in. So there's all of these different things that are going on at once. And our department even looks further, and we have a meteorology section in our department as well. So the winds, the sun, all of these different elements, even outside of the water, are influencing the system that you're studying. And then, of course, we have people. That kind of complicates this whole model as well. So a lot of what I do in biological oceanography, a marine biologist could do as well. A lot of the studies that I've done are very similar to marine biologist studies that have been done in the past. But I tend to ask a lot of bigger picture questions, and I always have a relationship with what's going on with the organism in context of the environment as well. So I'm going to go through quickly my PhD research, just part of it. So I'm working on pipefish species that are in the Indian River Lagoon, and these are just some of my research photos from being out on the water. Whenever you guys go over the causeways, if you're not familiar, you're crossing over the Indian River Lagoon. And I think it's pretty. I know it's not the Caribbean, but I like it. It's home to some pretty amazing organisms, manatees, alligators. We get beautiful space shuttle launches over the lagoon. Just some general information if you're not familiar with it. It's 156 miles long. There's 5 main inlets that connect the lagoon to the ocean. There's Ponce de Leon Inlet, which is furthest in the north, and then Jupiter, which is in the south. The average depth of the lagoon is only about 6 feet, so there are some areas you can walk straight across. The salinity varies quite a bit depending on how close you are to an inlet and how close you are to a creek, river, or canal discharge. And because the lagoon is so long, it actually straddles temperate and subtropical zones. So there's quite a difference in temperature between the north and the south. And the salinity and the temperature is really what allows the lagoon to be a very diverse place. And because it's home to 7 species of seagrass, it's actually considered one of the most biologically diverse estuaries in North America. And besides the seagrasses, it's home to a variety of different species of drift algae and attached macroalgae. One of them I'll talk about is the Caulerpa prolifera. And then amongst all of this habitat, there's actually 7 species of cygnathids that you can find there. When I talk to people and I say I work with seahorses and pipefish in the lagoon, they're like, there's seahorses in the lagoon? And yes, there are. Not so many right now. I'll talk about that. But it's a beautiful place, and there's a lot that's going on in there. There's a lot of really amazing organisms and habitats there. But unfortunately, a lot of that is getting destroyed or has been destroyed. I'm going to go through some of the quick anthropogenic threats to the Indian River Lagoon. One of them is nutrient addition. Fertilizers, if you fertilize your lawn at home, try to use a long-release fertilizer. If you don't, all of that gets washed off with stormwater into the lagoon, and it leads to phytoplankton blooms and excess nutrients, which degrade the system. Pet waste, if you have pets at home, please pick up your dog poop. That is also nutrients that are getting added to the lagoon, as well as coliform bacteria. I swim out there, so please don't get me sick. Pick up your doggy poop. Petroleum products, if you have any leaky cars, make sure that you fix leaks as quickly as you can, because all of that just gets washed out. And also make sure you dispose of any oils after an oil change at your local like AutoZone. You could just bring in oil and they'll dispose of it properly for you. So all of these things are being added into the system through stormwater. When Florida has home to lots of hurricanes, tropical storms, if any of you have been here since 2004. So we get these rapid quantities of water that builds up on land. And when Florida was being developed, we didn't want houses to flood. So the developers basically created lots of canals and ditches, not only for homes, but also for agriculture, to get that water that comes so quickly and so fast, or so much quantity, away from the land as quickly as possible. So a lot of those canals and ditches just go right out into the Indian River Lagoon, and that water is not treated in any way. So in the first 1 inch of rain, 90% of the pollutants are contained within that. So it's really important to try to find a way to treat that first flush of rainwater to get rid of the nutrients, get rid of the petroleum products, to try to reduce their occurrence within the Indian River Lagoon. One of the other components of stormwater is what we call fine organic rich sediment, and we nicknamed it muck. And this is from people's topsoils. It's very slimy, it's oxygen deprived, it has a horrible smell to it, and it can actually occur in like feet that like 3 or 4 feet deep in some areas of the lagoon. So just imagine walking through this slimy, mucky, nasty stuff. That's covering seagrass beds, that's covering sand habitat, and that has been a major factor in the depletion of hard clams throughout the Indian River Lagoon, because it smothers out the clams. And it also prevents the juveniles from being able to settle and grow. And when there's a storm event, that muck gets turned up in the water column, and it causes issues with turbidity, which doesn't allow the light to penetrate and allow for seagrasses to grow. There's also been a lot of loss of coastal habitats. We've lost marshes, mangroves, and wetlands. Coastal wetlands are important, as you know, filters to try to prevent a lot of these pollutants, natural and unnatural, from getting out into the lagoon. There are filters, and we've built homes on them, we've built farms on them. So that's been a major issue. And then we've lost a lot of these other habitats, which are important homes for juvenile fishes as well. And then we have some direct impacts like crop scars, which actually destroy the seagrass habitat as well as disrupt the sand. And then boat wakes as well cause a lot of coastal erosion. So in summary, all of this leads to potential habitat loss in the lagoon. So one of the things I'm really interested in is protecting this habitat. And because cygnathids are very attractive, they're an excellent flagship species. You already have people's interest when you talk about seahorses. So when you start talking about seahorses' habitat and how that's declining and how people can help, you've really opened up an opportunity to have a dialogue with the community on how they can have a better relationship with their coastal environment. So from the literature that's available, everyone says that cygnathids love seagrass. It's a very important ecosystem for them. But I'm very curious, what happens in a diverse system when you have 7 different species of seagrass? You have lots of macroalgae. Do they still love seagrass, or do they like algae more? You know, what is the most important habitats for them? And how strong is that association? Do they only like certain species of seagrass? Do they only like certain types of algae? And what happens once you identify the habitat that they like? What happens when that habitat changes? How is that going to influence their population? And those questions are really important to trying to understand the links between humans and that water environment. You can have that conversation with the public. So these are some of my objectives. I wanted to see if stigmathids have a preference for a specific habitat type, if they have a preference for a specific density of those habitat types, if it changes between daytime and nighttime, and if changes if there's a presence of a predator or an absence of a predator. So I'm going to cover the different species of submerged aquatic vegetation. I'm going to go through my setup really quickly because we're running out of time. I had 20 aquariums. We have a Vero Beach Marine Lab that the school owns that I was able to work in. There was filtered flow-through seawater in the lab. I had 12-hour light-dark cycles, so they had special grow bulbs during the day, and then at night I had red LED lights that kicked on, and that allowed me to make nocturnal observations. And then the sand that was used in the tanks was collected from the lagoon. So to test the different species, SAV is submerged aquatic vegetation, so it covers all types of algae as well as the seagrass. So the seagrass species I used was Haliduli wrightii, and then the Caulerpa prolifera is very seagrass-like, but it's actually an attached macroalgae. And then drift algae is another algae that is found throughout the lagoon, and this one can be attached, but oftentimes it's just in loose clumps. And they can, all three of these habitats are very extensive, particularly in the Banana River, which is where the focus of my research was. So once the habitats were collected, we cleaned them up to make sure there was no organisms on there. Everything was based on the natural density of seagrasses. So if you have a 15 by 15 centimeter area of really dense seagrass in the Indian River Lagoon, the maximum number of shoots of seagrass you can have is 70. So I went ahead, I counted out 70 seagrass shoots, I cut off the above ground biomass and weighed that out. And then I used equal quantities of the Caulerpa and then the drift algae, so they had equal biomasses of all three species that were available. And they were put into each of the mesocosms, and they were randomly assigned where they were in the tank. So I used two different species of pipefish for these studies. I used male and female Gulf pipefish. They're called Stigmathus govelli. And then I used a juvenile Stigmathus louisianae. These are called the chain pipefish. And out of the hundreds of Stigmathus louisianae that I found in the Banana River, none of them were reproductively active adults. All I found was juveniles. So the Banana River really seems to be a very important juvenile nursery habitat for these organisms, which was unexpected as well. And then for my predator treatments, I used a blue crab, and this was a visual predator. It was set up in a tank next to them in an identical tank, so the pipefish would be able to see them but not interact. So for the tanks, they got one fish per tank. I watched them every hour for 24 hours, and I marked down if they were in one of the habitats. And I also marked down if they were in the water column, swimming around, or if they were hanging out on the sand. So I ended up having 12 observations in the daytime, 12 observations at night. And I determined the percent of occurrence in each one of the available habitats for daytime and for nighttime. I did a multivariate analysis of variance, and then I did a post hoc analysis with a Mann-Whitney. So this is the chain pipefish, Stigmathus louisianae. So in this species, there was no effect of predator presence or absence. There was no effect of time of day. These guys were real specialists, that they liked the seagrass, which is the big green bar, and they didn't like anything else. They might have small occurrences there, but they were not statistically significant. And that huge difference between the two of them really shows that they like seagrass. So with the other species, the Gulf pipefish, I had a very surprising finding. It started one night where it was like 3 in the morning, so you're working in red lights in a completely dark lab. And I'm pretty good at finding pipefish in habitats, and I could not find this pipefish to save my life. And I waited an hour to see maybe if it would pop up and I'd be able to see it, and still couldn't find it. So I started taking out the habitats from the tank. I looked through every blade of seagrass, every piece of drift algae, every piece of Caulerpa, still couldn't find it. The only thing that was left in the tank was the sand, and I couldn't see this pipefish anywhere. And it's not a little pipefish, it's probably about that big. And I started raking my fingers through the sand, and I hit something, and I pick it up, and it's the pipefish, and I thought it was dead. And I looked at it, it was still breathing, and I put it gently down on the sand, and it wiggled, and it just buried itself in the sand. So I did a lot of literature research, obviously, before I started up these experiments, and all the pipefish research that's been done looking at vegetated areas versus non-vegetated areas, pipefish always choose the vegetated areas. So I wasn't even thinking of the sand as a habitat until I started working with these guys, and they actually will bury themselves in the sand. And over all my experiments, it was pretty consistent that 30% of all of the males and the females buried themselves in the sand throughout the experiment. So it's kind of interesting finding there. So with the females of this species, there was an effective day and night where they preferred the sand habitat during the day, and then at night they would move into the habitat. And then in the presence of the predator, they actually preferred the seagrass and the drift algae habitat compared to being in the sand. So definitely there was that predator effect where they were afraid of getting consumed, so they were a little bit more protective of themselves. With the males, it was actually a little bit different. There was a day-night finding as well as significance. During the day, they were more on the sand, but there was a very strong preference for seagrass at night compared to with the other species. It was kind of a mix of drift algae and seagrass. And then in the predator treatment, they sort of preferred all habitats equally with the males. And then for the second set of experiments that I did, I was looking at density, and I'm just going to show you the results from one of the species here. So within the Indian River Lagoon, there's a St. John's River Water Management District that goes out in the summer and in the winter, and they have 6 transects throughout the lagoon where they look at how seagrasses are doing. And they've been conducting this research since 1994, and in 1994, the water clarity of the lagoon was very poor, and seagrasses were in bad shape. So they decided that they needed to go out there and start monitoring and trying to figure out what was going on with the seagrasses and if their efforts to improve the water quality were being successful. So this is just over time here on the x-axis. The length of the seagrass beds have actually been increasing throughout the Indian River Lagoon. So you look at that data and you say, great, all of these efforts we're making to improve the water of the lagoon have been paying off. But if you actually look at the density of the seagrass within the lagoon, it's actually declined. And in some areas, the density has decreased by 50%. So although the beds are getting longer, the seagrass is disappearing still. So for me, I wanted to ask, since I know that one species in particular, the Louisiani, loves seagrass, do they have a preference for a specific density of seagrass? So here I did a treatment that was 100%, so that's 70 shoots of seagrass. The 50% cover would be 35 shoots of seagrass and then 17 shoots of seagrass. And these were also randomly placed inside of the tank. And so this is with the chain pipefish. And once again, the specialist that loves seagrass loves 100% coverage of seagrass, and it was did not like any of the other ones. So what's going to happen to this species as its habitat continues to decline? It's kind of, this species is definitely at risk, and their populations are within the Indian River Lagoon. So I wanted to talk about, if you guys have heard about this in class, the phytoplankton bloom that happened this past year. It actually began in March in the Banana River, and it was green algae called Resultor that started blooming, and you could be in ankle-deep water and you couldn't see your feet in the lagoon. It really just blocked out the sunlight, and it was incredibly dense. It spread from the Banana River throughout a majority of the Indian River Lagoon. It was in the northern IRL, parts of the Mosquito Lagoon, all the way down to Fort Pierce Inlet, so that's that red area. And the green area was the areas that were free of the phytoplankton bloom. So right about in July, when I was doing my field research, the bloom just got at its worst, and just the seagrass started declining. Within 2 weeks, I went to an area that was 100% seagrass, and when I came back, it was gone. It was just sand. That's how quickly the seagrass disappeared. Phytoplankton blooms are natural, but this event in particular was a combination, they think, of drought conditions allowing specific species that were tolerant to high salinities to thrive, and then there was a rainstorm that just added that little extra kick of nutrients into the system and caused this massive phytoplankton bloom. And it just ended a couple months ago, and now the lagoon has amazing clarity to it, and you can start seeing the seagrasses coming back. This is a graph from St. John's as well of each of their different transects. This is going from the north of the lagoon down to the south. And this is comparing the transect length from 2011 to the transect length in 2010. So as close as those red bars get to 100, that means that all of the seagrass was lost on that transect in this year. And then the further you get to the opposite, that means that the green bars mean that there was growth of the seagrass. So you can see that in a majority of the Indian River Lagoon this year, we actually lost large quantities, if not all of the seagrass for some of these transects. And it was quite shocking going out there. And this is the original graph that I showed you with the transect length and showing this year's densities. And this is actually the lowest density of seagrass that we've had since St. John's started monitoring their transects back in 1994. So just kind of thinking, all right, are these seagrasses going to be able to bounce back? Seagrasses are generally very resilient, and they do have that below ground biomass that's still out there that hopefully they'll be able to sprout from. And I was just out a few weeks ago, and I am seeing seagrass come back, but will it come back as dense as it was? We don't know. And all of those fish that were relying on that seagrass for their habitat for most of the summer didn't have it, and they probably fell prey to predation. So it will be very interesting to see what happens not only with the seagrass habitat, but all of the fish populations that rely on it. And with our specialists, the chain pipefish that preferred seagrass, preferred 100% cover seagrass, after the seagrasses declined, I've only found one out in my research sites. And I used to be able to go out in a single day and collect 100 of them. So it definitely shows that their populations are going to be impacted by an event like this. So those are just kind of the major conclusions. There are differences between the species. There were differences just kind of generally between the males and females. We have our specialist, and then we have our generalist, which was the Gulf pipefish. So this is just part of my PhD research. I'm also comparing field data. I was looking at 100% seagrass and 50% seagrass cover. I was looking at the species abundances of pipefish. I'm looking at prey selectivity and seeing if those differ in these two different densities of seagrass and also their reproduction. So once I'm done, I hope to teach. I really enjoy doing research. I really love teaching. I'm also looking for postdoc positions, and I'm just kind of offering this information if you guys are thinking of continuing on and doing your PhD. And when you're trying to analyze all this data and get everything ready, you're also trying to think about the next step as well. So it's a little overwhelming. I'd like to continue studying these habitat preferences of cygnathids. I was hoping to work with the dwarf seahorse as well and do the same sets of experiments, but because of the seagrass loss, those populations have disappeared as well. I used to be able to collect hundreds of dwarf seahorses in certain areas that I knew where their populations were, and I only caught 3 this year, so it's quite shocking. But seahorses are a great conversation, and so if I was able to find the same strength of relationships that I found with the pipefish, it would just offer another way to communicate with people. One of the important things that I've learned throughout my degree and in my department is it's not so much, you look at the organism, you look at their habitat, and in the cases of seagrasses, so much of what affects these organisms is outside of the water. It's within the watershed, it's among people's homes. So I really want to be studying the effects of freshwater discharge, finding ways to improve the stormwater release into the system to try to reduce some of these negative impacts on these habitats, and continue to use cygnathids as a flagship for these important systems. So thank you guys very much for your attention. There is my email address. I'm sorry I'm done with my research, so I don't really need any help, but if it was a year ago, I would have had all of you guys come in to help me out. I definitely needed field assistance all summer. So thank you, and any questions, I feel free to answer. So thanks. Probably more than you ever wanted to know. No question. Yeah.
Has there been any research to show like in maybe another area that's had a habitat die off, how long it takes for them to recover?
Not specifically with cygnathids. No one's looked at the effects of any type of habitat decline on their populations.
All right, if you guys have any questions about women in science and engineering, the future activities, programs we're doing, please contact myself, spring@varsity.edu, or I'm located in Building 5, Section 5135. And this is Nancy Cummings. If you have questions for any of us, we will stick around for a little bit. Have a great day.
Thank you.
If you need proof of attendance, our associate provost, Dr. Dr. Massey has tickets to give